Hello viewers, let's talk about the difference between mass and weight. Out of the scientific concept or context, this mass and weight are treated equally or they are treated the same thing. But scientifically, mass is different from weight. So let's find out. First is, let's define mass. Mass is the measure of the amount of matter in a body. Mass is denoted using the small letter m. Again, mass is the amount of matter in a body. Now let's see what weight means. Weight is the measure of the amount of force acting on a mass due to the acceleration due to gravity. And weight usually is denoted by capital letter W. So weight is a force acting on a mass, while mass is that amount of matter present in an object. Weight, on the other hand, is that gravitational force of attraction exerted on an object. So let's talk about other differences between mass and weight. Another is mass is a scalar quantity while weight is a vector quantity. What does it mean? When we say scalar quantity, these are quantities having only magnitude. When we say vector, vector quantities are those having both magnitude and direction. Now for mass, we say it's a scalar quantity because we usually just write it like 1 kilogram, 3 grams, 10 grams, or 50 kilograms. These are all scalar quantities, having only magnitudes without direction. But when we say weight, it's a vector quantity because it's a force and force is a vector quantity. They both have magnitude and direction. Now another difference, mass does not change according to location, while weight varies according to location. So when we say mass, wherever you go, even to other planets, your mass will never change. It will be the same wherever you go, wherever you are. While weight, it varies from place to place. If you go to other planets like Jupiter, it will have a huge difference in weight. So weight is changing. It can be higher or lower depending on your location. Now next, mass is measured in grams and kilograms, while weight is measured in newtons, which is a unit of force. Whatever type of force is, it's always measured in newtons or expressed in newtons or capital letter N. One last difference, mass doesn't depend on the effect of gravity, while weight depends on the effect of gravity. What do we mean? Mass doesn't depend on the effect of gravity, so it's not affected by gravity. Wherever you are, even on other planets or on the moon, where the gravity may be higher or lower, it will not change your mass. Your mass will be the same wherever you are. Well, for weight, since it depends on the effect of gravity, your weight will change. It can be higher or lower depending on where you are, depending on the gravity on that place. Now let's deal with sample computations on mass and weight. Compute for mass, given the following, force is equal to 140 newtons and acceleration equal to 10 meter per second squared. Now, this formula that we use here is derived from the second law of motion, which is the law of acceleration. The equation is mass equal to force divided by acceleration. So, if we substitute the given values, we have there mass equal to 140 newtons, which is the force, divided by the acceleration of 10 meter per second squared. Now, if we are going to expand Newton, this becomes mass equal to 140 kilogram meter per second squared divided by 10 meter per second squared. Now let's divide 140 divided by 10 is equal to 14. We cancel out the meter per second squared. What is left is kilogram. The final answer is mass equal to 14 kilograms. Now let's proceed to computation for weight. The given are mass equal to 8 kilograms and acceleration due to gravity equal to 9.8 meter per second squared. That is a constant value for A sub g. Now the formula would be W, or the weight, equal to the mass m times the acceleration due to gravity A sub g. We will just multiply mass and A sub g, or the acceleration. So substituting, we have W equal to 8 kilogram, the mass, times the acceleration due to gravity, 9.8 meter per second squared. Now 8 times 9.8 will give us 78.4. Now we will just write down the units kilogram meter per second squared. Or your final answer is the weight equal to 78.4 newtons. And the direction of this weight is going or towards the center of the earth because this is weight. If you want to compute your weight on the surface of the earth, whatever is your mass, let's say you are weighing 40 kilograms. So 40 kilograms, you just multiply it to 9.8 meter per second squared. That will be your weight on the surface of the earth.